Way 38 has to deal with how elements behave chemically based off their location off the periodic table. The important thing to remember here is that elements that exhibit similar chemical properties are going to belong in the same group, and that's primarily due to them having the same valence electrons. Notice everything in group 1 contains its last digit as 1, and everything in group 18 contains its last digit as 8. All these elements are grouped accordingly to the number of valence electrons present in that outer shell, the last digit present in their electron configuration. If you recall, all atoms are trying to achieve stability. Stability for an atom means that its valence electrons, are completely filled. The only column that exhibits that property is column 18 or group 18. Notice they all have what's called an octet, a set of 8 electrons with the exception of helium. It's for this reason that all these elements in this group are considered inert or non-reactive. They don't tend to react with other elements or atoms in the periodic table because their atoms are already stable. Everything in group 17, however, has 7 valence electrons. Its last digit is 7. Therefore, when these atoms bond with or react with other atoms, they will bond in such a way such that they end up taking an electron from another atom to completely fill its outer shell. Everything in group 1, however, with its last digit as 1, merely has to lose that 1 valence electron in order for it to achieve stability. Notice if sodium loses 1 of those valence electrons, it'll have an electron configuration of 2-8 and will therefore be stable. Important thing to note is all the atoms which represent stability are represented by group 18. They have a completely filled outer shell. So let's exploit this property when we're answering some questions. Many scientists made observations of the elements that led to the modern periodic table. In 1829, Dobereiner found groups of 3 elements that have similar properties and called each of these groups a triad. Dobereiner noticed a relationship between the atomic masses of the elements in each triad. Triad 1, shown in the table below, consists of sulfur, selenium, and tellurium. The middle element, selenium, has an atomic mass that is close to the sum of the atomic masses of sulfur and tellurium divided by 2. For example, 38 units plus 128 units divided by 2 equals 80, which is close to 79 unit value in the table. The other triads shown in the table below demonstrate the same mathematical relationship. Explain in terms of electrons why these atoms exist, why the elements in triad 2 have similar chemical properties. So we have to know something about their location on the periodic table and mention the word electrons in our answer in order to properly answer this question. Okay, if you notice, all the elements in triad 2, calcium, strontium, and barium, all belong in group 2, and they all have 2 as their valence electron number. Therefore, elements in a triad, such as triad 2, have similar chemical properties because they have the same number of valence electrons. Notice my answer contains the word electrons in it because the question asked me to explain in terms of electrons. You must mention whatever term it says in the Regents problem if you're going to get full credit for this answer. Next question. Explain in terms of electron configuration why arsenic and antimony are chemically similar. For 2 atoms to exhibit the same chemical properties, they have to have equal valence electrons, and those are typical of a group. Therefore, you should say something like arsenic has an electron configuration of 2, 8, 18, 5, and antimony has 2, 8, 18, 18-5. Notice they both end in the digit 5. They are chemically similar because their electron configuration ends with the same number of valence electrons. So notice that my answer features the word electron configuration, and thus this answer would give you full credit. Basically, same valence electrons, same chemical properties. Which 2 elements have the most similar chemical properties? For problems involving the periodic table, it's very helpful to know the symbols ahead of time, but if you didn't, you could always look up these element symbols on table S. You'll find that the only answer choice that makes the most sense is answer choice 1, beryllium Be and magnesium Mg, because they both belong in group 2 of the periodic table. Group 2 elements have a last digit of 2 and therefore are going to exhibit the same chemical properties. Rubidium and cesium have similar chemical properties because in the ground state, the atoms of both elements each have Looking up their symbols, you can verify that rubidium and cesium both have 1 electron in their outermost shell. How do you know? The last digit of Rb and Cs is 1. Therefore, they have the same number of valence electrons. Electrons in the outermost shell just refers to the valence electron. Next problem. Chlorine and element X have similar chemical properties. An atom of element X could have an electron configuration of Notice this problem is asking you to apply the definition of valence electrons as well as what it means for two things to have the same similar chemical properties. For element X and chlorine to have the same chemical properties, they must end in a digit of 7, which is the same as chlorine. Therefore, the only answer choice that makes the most sense is answer choice 4, because X and chlorine both have 7 valence electrons. Therefore, element X is likely in group 17. Which elements have the most similar chemical properties? You selected oxygen and sulfur as your answer. You got it correct, primarily because they both belong in group 16 and therefore have 6 valence electrons and therefore have the same chemical properties. Which elements have the most similar chemical properties? If you selected 3 as the correct answer, you got it right. Mg, Sr, and Ba all belong in group 2. They all end in a digit of 2. In their electron configuration, they all have the same number of valence electrons. So when it comes to these problems, remember that if you belong in the same group, you're going to exhibit the same chemical properties because you have the same valence electrons. And it's those valence electrons that are involved in chemical bonding. Therefore, they're going to behave the same way chemically. Hopefully this was helpful, and thank you for watching.